Right, this video is on AP Precalculus Unit 1, 1.2b, rates of change. There is already a 1.2a video, so you might want to check that out. So this one has more questions on it. This is basically just practicing this section uh, with various practice problems. So let's get started. For each scenario below, determine whether the two variables have a positive rate of change or negative rate. And by the way, these questions in the PDF form is in the link that you might find in the description. So you might want to download if you want that. Okay, we have to determine whether the rates of change, the rate of change here is positive or negative in the following word problems. Okay, the amount of money in a vending machine versus the number of items remaining inside the vending machine. So it makes sense that this should be the rate of change should be negative because the amount of money when it goes inside the vending machine as in the amount of money increases, the number of items remaining inside will obviously keep decreasing because those particular items are being collected in exchange of the money. So this is negative, clearly. We're on the next one, the number of days since the flu season began versus the number of people that have caught the flu. They should have a positive rate of change because as the number of days since the flu season began increases, the number of people who are infected or who caught the flu increases, right? That makes intuitive sense. So that has to be positive in nature. Rate of change should be positive in nature. The number of years since 2000 versus the number of Teslas on the road, that is also positive because as the number of years are passing, the number of Teslas on the road are increasing. So rate of change is positive. And the number of miles driven since last filling up a gas tank versus the amount of gas left inside the tank. This is negative because more miles are driven, less amount of gas is left in the tank, right? So this has to be, the rate of change has to be negative in this case. Right, here we are given a function cubic using graphical calculator to find the values of g for the x values as indicated in the table, and use your graphical calculator again to find the AROC in the following interval. Show your computation. So this is just a calculator active question. I'm gonna do that on my calculator. I'm just gonna write my answers over here and you can verify yours as well. 0.5, I'm getting 0.45. Over here, I'm getting negative 0.456. Here, I'm getting negative 0.582. 0.9, I'm getting negative 0.6034. Over here, I'm getting negative 0.5954. At 1.1, I'm getting negative 0.498. Over here, I'm getting negative 0.264. And over here, I'm getting 1.35. So this is just a simple calculation where I'll just show one as an example. I think you will understand the rest. For example, if I want to find g of 0.5, all I have to do is replace every x with 0.5 over here. So this first x is replaced with 0.5, the next x is replaced with 0.5, and then plus 3 remains as it is. You put this into the calculator and you will get 0.45. Next, they are asking the AROC in this interval. So we know very well that the formula I'll just show for this one. So the formula for AROC in this case is going to be f of 1.5 minus f of 0.5 over 1.5 minus 0.5. What is f of 1.5? Once again, you are going to, it will not be f, it will be g because the function is denoted by g. So just the way we found g of 0.5 as 0.45, likewise, we'll find g of 1.5, which is just 1.35 from the table. And I'm just going to plug in the numbers here. And that will give us the answer as 0.9 in case 1. Likewise, if we do all of these, I'm just going to write my answers. You can verify. This one is 0.48. This one is negative 0.01. And this one will be 0.4002. Based on the average rate of change from B, do you think the rate of change of G when X, what do you think of is the rate of change of G when X is equal to 1? Give a reason for your answer. So X is equal to 1, we just have to see that where is it lying, right? Between which 2 points? And in the following intervals, the closest point, the closest points in the vicinity of 1 is the last option, right? Because 0.99 and 1.01 are really, really close to 1. Obviously, these are also in between, 1 is also in between these points, but this is very close. And in all such questions, we will say that the rate of change at 1 can be approximated as the average rate of change between these 2 points, which is going to be 0.4002. And the reason of your answer is pretty much just what I said. Right, I hope this one makes sense. Let's move on to the next one. Here we are given the graph of H along 4 points ABCD. Sketch a line tangent to the graph of H at the 4 points indicated. Okay, so we just have to draw a tangent line. So the tangent line at A is going to look something like this. At B, it's going to look something like this. At C, it will be almost horizontal, I think. And at D, it will be sort of like, okay, it's difficult to, okay, yeah, that makes sense. This one. Now they are saying that order the rates of change of H from least to greatest at the points A, B, C, and D. So here we are looking basically for steepness, right? Which one is most steep? I think between A and D, it's difficult to see in this way which one is more steep. Let me redraw D. Maybe we'll figure something out. D will probably not like this, definitely. D. Okay, this one makes sense. Let me redraw. All right, I think I'm going to go with this one. So this one makes sense. And this one, if I were to redraw, let's see how will this look like. Okay, I think this is okay. It's very difficult to figure out that the rate of change between A and D, which one is more steep, but I think the way I'm seeing, I think D is more steep, right? So I'm going to go with D being the largest. D is the most steep. So it will be D followed by A. And then obviously B is B is less steep than A and D, and C is not steep at all. It's just a horizontal line, so there is no rate of change at that point. So I think this should be the comparison. Right, here they are talking about for each of the following statements about the graph H shown above, circle the correct answer and the correct reasoning. So from point A to B, the rate of change is increasing or decreasing because H is dash or dash in that interval. Obviously, the rate of change is increasing because it is a smiling phase function, right? And a smiling phase function is concave up. So it is increasing because it is concave up. Between B and C, they are asking whether the graph of H is increasing. Also, be careful. They are asking graph of H is increasing or decreasing. That's pretty straightforward because between B and C, obviously the graph is climbing, right? So it has to be increasing. And when the graph is increasing, the rate of change is definitely positive. Don't be confused by saying that the rate of change is increasing, because if I say the rate of change is increasing, I'm basically interested in knowing whether the function is concave up or down, which is not the case in this case. Okay, last one, the rate of change is increasing or decreasing because H is decreasing or concave down. Again, between C and D, obviously the function is decreasing as well, but this reason is of concavity. This is concave down function. Clearly, this is concave down function. As we can see, it's a frowning face function. And the reason for concave down is that the rate of change is decreasing. Because whenever the rate of change is decreasing, it is concave down. And when the rate of change is increasing, it is concave up. So that was our last question in this worksheet.